Okay, this is something that I think is very different and very exciting, and you can tell is since it's serious because I actually prepared a PowerPoint rather than just drawing on some random document. And so what this is sort of inspired by a couple, I guess, recent activities. I've seen a couple sort of calls for research, basically, and contributors go out and reinforcement learning and with OpenAI Gym and such, and in addition to some more quantum focused fields. And so, really, what this is about is truly an open call for contributions. So, specifically, um, there was a I uploaded a paper just a few days ago, actually. Today's the 5th that I'm recording this on, and I submitted it, and it went up on the 3rd. Um, and this was a paper a long time in the making. I applied to get funding for it uh, like almost a year ago, probably, maybe only 8 months or so. And then I ran all the experiments and wrote it up, and so this has been a long time making. Basically, what it is just it's a really straightforward idea, and that is, we have a lot of problems. How are we going to optimize these quantum circuits, be it for QAOA, VQE, or any, pick your favorite application, right? Um, well, the question is, how do we optimize them? Some people, use Atom. You'll see that in a lot of quantum RL papers. You'll see BFGS and like the original data re-uploading paper use that. So, how are we supposed to do this? It kind of seems like you pick at random or you pick a few and then try to guess. And so the goal of this was simply, well, there's lots of problems, there's lots of optimizers. Let's just try all of them and see what works, and then we can make empirically informed judgments about it. And this is the funding for this did come from the SPELL Open Research Grants. So thank you to them. So first I'll motivate to keep everyone intrigued. I'll motivate exactly why you might be invested or want to contribute to this project before I actually talk about what contributions will look like. And the first is, of course, a simple, maybe idealistic purpose, and that is to advance the knowledge of the field. I guess that's the simple reason to do any sort of scientific endeavor, and what a lot of scientists claim their own motivations to be. Of course, I don't know how many I actually believe that to be truth for, and so we'll move on to the more realistic motivations, which is fine. Any and all contributions, of course, will be acknowledged. And I plan on putting out version 2 of this paper probably in a few months. And it'll be uploaded to arXiv, just like the first one, with all relevant authors added. So if you make non-trivial contributions to this work, I'll be happy to, and you want to review, obviously, you have to actually read the paper that your name is going on, but I will be happy to add anyone, regardless of their skills or backgrounds or education, that offer meaningful contributions to this project. I'll be happy to add them to this paper because that's what research is all about: collaborations, working together to advance knowledge. Additionally, once this V2 goes out, I'll submit it to a journal, of course, an open source or open access journal, because that's what I believe in. And so I don't know how much that matters to people. If you're like me and you really value peer review, then this might be more important than others. I'm not going to promise this is going to be the next big thing, but I do think this has the potential to be a well-cited piece of work, simply because there's not a lot of other work. There was a recent one that focused on some gradient-free optimizers for VQE problems that I mentioned in the paper. But I think there's, if people are going to write a paper, they're going to be like, okay, I use this optimizer, atom learning rate 0.1, and now they can just add a little tag saying because it has empirical justification. Whereas before there was just nothing there. People would just say I use this optimizer, and so I could see, this being highly cited sort of just because everyone who's optimizing things just makes decisions and then just cites this as a reason why, whether or not it was truly the reason, but that's how academia goes. Of course, I could be entirely wrong, but that's just, motivating. I think that would motivate me to contribute, so that might motivate you. Now I'll actually explain what contributions are. So basically, I'm just looking to expand this work. You'll notice in the limitations section of this paper, there's examples, but I want to add a number of things to it. I also linked the GitHub, by the way. It will be below, as always, where you can find all of this, all this stuff, this information. But basically, there's a number of things that could be contributed. You could add real, i.e. molecular or Ising model Hamiltonians to the VQE problems. There's new QAOA problems. There's different optimizers. There's different shot models, adjustments for shot budgets, entirely new problems, or even things that aren't listed here that I haven't thought of at all. All of these are welcome contributions. Additionally, improvements in the analysis section is incredibly valuable. Right now, I struggled a lot with how to present the results, and I don't think that they're in an optimal way right now, I'll be honest. There's a table and 2 bar graphs, and I don't think either of them are the best way that it could be presented, but I don't know what the best way is. And so I welcome contributions in the analysis of the data as well. So now the how part, you see any of these problems, you want to take them on, you just make an issue on the GitHub. I would advise you to make an issue before starting any work, because if you do a ton of work and then it's not actually that good, or it's not sort of the direction that's wanted, then you're going to have to do a lot of work for nothing. And so you might want to, we can talk about it in that issue beforehand. And then the only other things are just the QML stuff should be written in TensorFlow Quantum just to be consistent across all the previous work, and so it follows the same sort of code patterns. There's no like coding requirement. I don't even use any code formatting. Just have the sort of optimization function and then the same sort of iterate loop. I don't really know how you would do it like otherwise, even if you wanted to. And then the results, there's an outlined result formatting into contributing.md. It's pretty straightforward. You just print the results or write them to a file. It doesn't really have that much of an impact. It's just you have to print them in a certain string format, which is fine. And that's it really. If you have any questions, you can of course comment them below, or you can make an issue on the GitHub. But hopefully this is an opportunity to both expand the science, and for some people, especially anyone early career, new to the field, I don't know, doesn't matter what your background is. I just look at the contributions. So, hopefully this can help some people too. But, even if only established people contribute, that's fine too. Even if no one contributes, that's fine too. I just want to put this out there and sort of try to encourage open collaborations in the field, and see where this takes us. So yeah, I hope you contribute, and I appreciate you listening.